This is new lesson, arithmetic progression, which is very important according to your SSC examination point of view. Arithmetic progression. So in order to understand arithmetic progression, we need to understand sequence. So here I am going to write some set of numbers. You need to identify those numbers. For example, 1, 2, 3, 4, 5, and so on. Second set of numbers are 0, 1, 2, 3, 4, 5, 6, and onwards. Another set of number 2, 4, 6, 8, 10. Same way, we can take another set of number as 1, 3, 5, 7, 9, and onwards. Look, all these series in set of numbers uh, have certain qualities. For example, and we all are aware with these set of numbers. This one is a set of natural number. This is set of whole numbers. This is even numbers, set of even numbers. These are set of odd numbers. So these set of numbers have certain names. So if you observe these numbers, they follow certain pattern. Same way, I can have another set of numbers like 1, 4, 9, 16, 25, and so on. Even this set of number has a specific pattern. Each term in this series is a perfect square of a natural number. This 1 is a square of 1, this 4 is a square of 2, this is square of 3, this is square of 4, this is square of 5. So this is a pattern. So any number, any sequence, any series which follows a particular rule or pattern is called sequence. But here we're talking about arithmetic progression. Arithmetic progression is also a sequence, but this sequence follows a definite rule, and that definite rule is the difference between any two consecutive terms of the arithmetic progression should be constant. For example, if you take this series, this fifth one, so first number is 1, second number is 4. So when you take out difference between 1 and 4, it is 3. Difference between 9 and 4 is 5. Difference between 9 and 16, 7. Difference between 25 and 16 is 9. Right? So these are differences between two terms 3, 5, 7, 9. But if you take this one, this fourth one, so 3 minus 1 is 2, 5 minus 3 is 2, 7 minus 5 is 2, then 9 minus 7 is 2. Same way, if you find out difference in this sequence, 2 minus 4 minus 2 is 2, 6 minus 4 is 2, 8 minus 6 is 2, 10 minus 8 is 2. Here 1 minus 0 is 1, 2 minus 1, 1, 3 minus 1, 1, 4 minus 3, 1. Same way, 2 minus 1, 1, 3 minus 2, 1, 4 minus 3 is 1, 5 minus 4 is also 1. So here we came to know that the difference between any two consecutive term in all four sequence is constant, means same number. Any two number you can subtract in this series, you will get 1. Any two number you can subtract in this series, you will get 1. Any number you can subtract, any two number you can subtract from this series, difference will be 2. Any two number you can subtract from this series, difference will be 2. But in case of these numbers 1, 4, 9, 16, 25, they also followed a rule. This is also a sequence. But when you subtract first term from second, difference is 3. When you subtract second term from third, difference is 5, right? So these are differences which are not same. Every time you getting different differences on subtracting two consecutive numbers. So this is sequence. 1, 4, 9, 16 is a sequence, but it is not an arithmetic progression. And all four, these four sequence number 1, 2, 3 and 4, they all are called arithmetic progression because the difference between any two consecutive term is constant. We will take one more example and we shall try to find out whether the given sequence is an arithmetic progression or not. So just look carefully on your screen. 1, 3, then next number is 6, 10, 15. This is another set. First we need to identify whether it is sequence or not. So in order to identify whether it is sequence or not, we just need to identify the pattern in the given set of numbers. So if you subtract 1 from this 3, difference would be 2. 6 minus 3, difference is 3. 10 minus 6, 4. 15 minus 10 is 5. Is there any pattern? Yes. Is there any pattern? Yes. Look at this. The pattern is what? This is my first number. When I'll add 2 in this, I'm getting 3. So every time I'm adding a natural number to the previous term in order to get the successive term. So when you add 2 in this, you will get next number, that is 3. When you add 3 in this number, you will get 6. When you add 4 in this number, you will get 10. When you add 5 in this number, you will get 15. Am I correct? So this is a pattern. This set of number follows a specific pattern. So you can say this is sequence. 1, 3, 6, 10, 15 is a sequence. But can we say that this set of number is an arithmetic progression? It is sequence because all the numbers in this series follows a definite rule, a pattern. So you can say, you can call them sequence. But my question is, does this equation is an arithmetic progression? Because for being arithmetic progression, the difference between any two consecutive numbers should be constant, which is not the case in this example. The difference between 3 and 1 is how much? 2. Difference between 6 and 3 is 3. So these two differences are not same. You can see difference between 3 and 1 is how much? 2. Difference between 5 and 3 is again 2, 2, 2. So all the differences in this example is same. That is called constant. But in case of this sequence, the difference between two consecutive number is not same. 3 minus 1 is 2, 6 minus 3 is 3, 10 minus 6 is 4, then 15 minus 10 is 5. So every time when we subtracting two consecutive term, any two consecutive term from this sequence, I am getting difference between them. Here difference is 3, here difference is 4, here difference is 5. So this series, this sequence and this series of number can be called sequence, but it is not an arithmetic progression. Because for being arithmetic progression, the difference between any two consecutive terms should be constant. Is it clear, everybody? In this question, we need to identify whether this given sequence is an arithmetic progression or not. So here, in this sequence, four terms are already mentioned. This is term 1. So I'll consider this 2 as term 1. This 4 is my term number 2. This 6 is term 3. And this 8 is term 4. So these are four terms: T1, T2, T3, T4. Now difference is what? Difference can be taken out between any two consecutive terms. So here T2 minus T1, that is second term minus first term. So my second term is 4 and my first term is 2. So on subtracting first term from second term, I'll be getting 2. Same way T3 minus T2. I am subtracting my second term from third term. So T3 is 6 and my second term is 4. So I'll get 2. Then I'll take T4 minus T3. My fourth term is 8 and my third term is 6. So 8 minus 6 is 2. So these are difference between any two consecutive terms. These are consecutive terms, T2 minus T1, T3 minus T2. Consecutive means one after other. So first term, and after first term you will have second term, right? So they are consecutive term. First and second term are consecutive term. So I am subtracting my first term from my second term. Same way, third term minus second term. So I am getting difference as 2. So here I will say the difference between two consecutive terms is constant. Therefore, the given sequence, I am talking about this. Therefore, the given sequence is an arithmetic progression. So this is the way to write your answer. Now, I'll take another question. This question number 2. 2, 5 by 2, 3, 7 by 3. So my second question is 2, 5 by 2, 3 and 7 by 2. 3 and 7 by 2. So these are four terms, term 1, term 2, term 3 and term 4. So again same procedure, T2 minus T1. So T2, that is 5 by 2 minus 2. So there is nothing in denominator, you can consider 1. So 1 into 5, that is 5 minus 4 upon 2. So 5 minus 4 will give you 1 by 2. So difference between first and second term is 1 by 2. Same way, I'll take T3 minus T2. T3 is 3 minus 2, that is 5 by 2. So here I can take 1. 3 twos are 6 minus 5 ones are 5 upon 2 ones are 2. So 6 minus 5 will give you 1 by 2 again. Then I'll take T4 minus T3. T3 minus T4 minus T3. So my fourth term is 7 by 2 minus third term is 3. I'll take 3 upon 1. So this will give me 7 minus 6 upon 2, which is again 1 by 2. So look at this, 1 by 2, 1 by 2, 1 by 2. So difference between any two consecutive term is again constant in this sequence. So here you can say, therefore the difference between two consecutive terms is constant. Therefore, the given sequence is an arithmetic progression. Now we will take one more example where the given sequence is not an AP, not an arithmetic progression. So I could take uh, question number 4. All looks like arithmetic progression. All are arithmetic progression actually. So these are some arithmetic progression.